Hi, Assalamualaikum, and very good day to everyone. Here we are from Group F today, going to do the summary and reflection about the thermodynamic web. So, our group task was to study the thermodynamic web and make a reflection on what you understand from the figure of the thermodynamic web. So, before proceeding further, our group would like to tell a brief introduction about what is this web. This web is actually one of the way to visualize the thermodynamic web when partial derivatives with temperature, pressure, entropy, and V. It provides rough permutations of partial derivatives between these properties relationships to make a complete set. The terms are related to other terms using either cyclic relation or Maxwell relation, which we will state a few minutes later after this. And both relations are represented with the icon in the top right corner of the figure, which will be shown in our thermodynamic part. So we will proceed with the mathematical relation. Mathematical relation here is actually we are deriving the general formula from the properties which the change in any intensive thermodynamic properties of interest Z can be written in two terms of partial derivatives of the two independent intensive properties x and y. So as you see here, this is a general formula, and from this general formula, we will come out with all the thermodynamic properties equations. So this is the initial process where and divide, and also including all the properties that we need to undergo partial pressure and come out with final formula using cyclic relation or Maxwell relation. So proceeding with the next part, which is the fundamental properties, the derived thermodynamic quantities. So we would like to share in this part is how we derive this thermodynamic quantities. So this actually we are want to share about derived properties which have Helmholtz free energy properties and Gibbs free energy properties. So you can see here these are the general formulas for enthalpy, Helmholtz free energy, and Gibbs free energy. And you can see here the Cp and Cv represent the heat capacity of the constant volume and constant pressure. So from what we understand is actually we're going to substitute all these initial formulas into the earlier formula that I showed to you, which was a general formula, and we're gonna undergo cyclic relations and Maxwell relations to come up with a thermodynamic formula. And the fundamental property relations, as I mentioned before, we will come up with these four formulas, which are du equals to T ds minus P dV, dH equals to T ds plus V dP, dA equals to minus P dV minus S dt, dG equals to V dP minus S dt. So these are the fundamental property relations after we substitute everything inside a formula. So, and the formula we will come up with final relations. With these expressions, one can write a number of unique relations by holding a certain values constant. By doing so, one yields. So by controlling one of the constants, because in here we will have two constants, by controlling one constant we will be able to get different values. As you can see here, for the first part you can see here, for example, du or ds and du and dv. When we control v, we will get the t. When we control s, we will get the negative p. And that's how it works for all the enthalpy and also Helmholtz energy and also entropy.
Okay, so let's get started from where Nizar left behind before. So next is Maxwell relations. Maxwell relations is an additional relations between thermodynamics properties, and their derivatives can be derived from the second derivatives of the fundamental property relationship. Basically, these relations are called Maxwell relation and can be obtained by noting that the order of partial differentiation of an exact differential does not matter. For example, we can equate the following two sets of partial derivatives of the exact differential du from the fundamental groupings, which is u as v. So the formula is on your screen. As you can see, by using the thermodynamics property relations in conjunction with the Maxwell relations, one can also write heat capacities in terms of T and S. So from the derived formula above, you can also insert the you can also write heat capacities in terms of T and S, which is shown at the bottom. So next we'll be moving on to the dependence of state functions on T, P and V. With the previous informations, one can find the dependence of any state functions on or quite easily. The procedure to do so can be broken down as follows. First thing first, start with the fundamental property relations for du, dh, dA or dg. Second, impose the conditions of T, P or V. Third, divide by dpt, dvt, dtv or dtp. And the last step is to use a Maxwell relations or other identity to eliminate any terms with entropy change in the numerator, if desired or as necessary. It depends on what you want. So the general formula for this is beta equals to 1 over v in bracket dv over dt p, and the second is k equals to negative 1 over v bracket dv over dp bracket t, where b and k are the thermal expansion coefficient and isothermal compressibility respectively. So the thermodynamics webs is as follow. From negative dp over dv s will go to dp over dsv. This is a cyclic relations, by the way, and it will go into negative dt over dvs and will be separated as cyclic relations. T over cv will be equal to dt over dsv. This is a relations without v, cyclic relations, and the next separation is going to be ds over dvt. And the Maxwell relations is P explicit EOS or B over K equals to dP over dtV. So moving on to the right from the top, negative dP over dVs will equal to ds over dvp, and the Maxwell relation in the case of dP over dTs, and there will be separations. The first left is negative dp over dst, and the first right is ds over dtp equals to cp over t. So this is a cyclic relations without v. So moving on to the Maxwell relations in the case of dt over dv bracket p equals to 1 over vv or v explicit EOS. So as you can see at the bottom, this is a web. So it will, from the bottom, it is dp over dv t. Cyclic relation without s will continue from where we end just now, which is as you can see on the thermodynamic webs. So that's all from us. This presentation is presented by Group F members. First, the Nizar bin Jalaluddin 197237. Second, Achira binti Azmi 199208. Third, Afifah binti Mama Arshad 198776. Fourth, Yuvaraj anak lelaki Kunalan 196320. So that's all from us. Thank you.